Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL May 2021 paper 1 time zone 1 past paper and we are solving a single question each day. Today we will be solving the question number 7. You will be getting all the questions in the playlist. The link to the playlist is given in the description area. So without any further delay, let us start with our today's session. Today we are solving the question number 7. It is a paper 1 question, so we are not allowed to use the calculator. And the maximum mark is 8. We do not have any subparts. Consider the quartic equation z to the power of 4 plus 4z cubed plus 8z squared plus 80z plus 400 equal to 0, where z is a complex number. Two of the roots of this equation are a plus bi and b plus ai, where a and b are integers. Find the possible values of a. Okay. We are seeing that the coefficients are all real numbers. Therefore, since these two are the two roots of this equation, a plus bi and b plus ai, the other two roots will be a minus bi and b minus ai. Right? So, let us write that. The other two roots are a minus bi and b minus ai. Now we can solve this in two ways. I'm showing you in both the ways in which you can solve this question. First of all, let me show you the shorter method, whichever comes to your mind, because you will not be thinking of alternative methods. That is there any shorter method? Is this the shortest method? You will never be doing that. So I'm showing you both the ways. Whichever comes to your mind, you have to apply that method to get the answer. Okay. So first is the method 1. Using the sum of the roots and the product of the roots property. The sum of the roots property will be, this will be equal to minus b by a. So sum of the roots a plus bi, I'm writing a minus bi just after a minus a plus bi. You can write these two after these two, it's up to you. A minus bi plus b plus ai plus b minus ai. This should be equal to b over a. What is b and what is a? Do not get confused with these ba, with these ba and these ba. They are totally different. This b is the coefficient of the z cube. And this a is the coefficient of z to the power of 4. So minus b will be, b is equal to plus 4, therefore minus b is minus 4 and a is 1. Therefore, this will be equal to minus 4 over 1. And if we add these 4 roots, we get 2a plus 2b, that is 2 times a plus b is equal to minus 4, which implies a plus b equal to negative 2. This is our equation number 1. And we'll be taking the second property, that is the product of the roots property. Product of the roots will be equal to minus 1 to the power of n times c over a. N is the highest power of the variable. Over here, the highest power of the variable is 4. So n is 4. And c is the constant term, which is 400, and a is the coefficient of the term containing z to the power of 4, which is 1. So n value is 4 and c value is 400, a value is 1. Therefore, we will be just substituting the values. N value is 4, c value is 400, a value is 1. Minus 1 to the power of 4 is plus 1. And 400 over 1 is 400. Product of the roots. Let us write the 4 roots. Okay, let me show you that this line becomes visible so that you can see the 4 roots. A plus bi times a minus bi times b plus ai times b minus ai equal to 400. And a plus bi times a minus bi is equal to a square plus b square. A square plus b square. And b plus ai times b minus ai is also equal to, it is b square plus a square, which can be written as a square plus b square. So this is equal to 400. Therefore, this can be written as a square plus b square times a square plus b square, which is a square plus b square whole square, equal to 400. Therefore, a square plus b square will be equal to, we are taking the square root of both the sides, will be equal to 20. Now, I am not taking minus 20. Why am I not taking minus 20? We do not know the values of a and b. But we know that a square is a positive number and b square is a positive number. A can be negative, b can be negative, but a square and b square, these have to be positive numbers. And when two positive numbers are added, the sum total is a positive number. Therefore, we are taking only plus 20, not minus 20. Okay. So this is equation number 2. A square plus b square equal to 20, and the first equation is a plus b is equal to negative 2. Let me write the first equation again. It was a plus b equal to negative 2. This is the first equation. So this gives us, I can express b in terms of a or a in terms of b. So let me express b in terms of a. So b is equal to minus a minus b. Sorry, minus 2. Okay. This is equation number 3. We will be putting this value or this expression of b in this equation number 2. So a square plus minus a minus 2 whole square is equal to 20. So a square plus minus a whole square is a square again, plus minus 2 whole square is 4 plus 4. And this is 2 times plus 2 times minus a times minus 2. is plus 4a. So it is plus 4a equal to 20. Therefore, 2a square plus 4a, and if we add minus 20 to both the sides, we get minus 20 plus 4 is minus 16 equal to 0. And I am dividing the entire equation by 2 just to reduce the coefficients. And we get a square plus 2a minus 8 is equal to 0. So 8 is 4 and 2. So I can write this as it will be plus 4a, plus 4 and minus 2. Okay, plus 4 and minus 2. Because 4a minus 2a will be plus 2a, and 4 times minus 2 is minus 8 equal to 0. Therefore, a is equal to either 2 or a is equal to minus 4. These two are the two values of a. They have asked for only the a, not the b, so we are interested in getting the value of a, not the value of b. Find the possible values of a. So this was the first method. Now let us come to the second method. Anyway, we will be starting in the second method also. We will be starting with this line that the other roots will be a minus bi and b minus ai. Okay. So therefore the roots are a plus bi, a minus bi, b plus ai, b minus ai. Since these four are the roots to this equation, the factors will be b minus a plus bi, b minus a minus bi, b minus b plus ai, b minus b minus ai. These are the four linear factors. This should be equal to the given equation, the p to the power of 4. I can bring in this equation because you cannot see it. A plus bi and b plus ai, these two are the given two roots. Let me just paste this over here. So this is equal to this is the left hand side, and this is the up to this part. Up to this part. I can just erase this. Yes. Okay, let it stay. Okay. So now we will be equating the coefficients to get the values of A and B. See, we can first of all try the constant term. Okay? How can we get the constant term? The constant term will be obtained when we multiply all these four roots rather. So first of all, let us multiply these two, a plus bi and a minus bi. These two when multiplied together will be giving us a square plus b square. And these two when multiplied together, b plus ai and b minus ai should also be giving us the same thing, b squared plus a squared. And when these two multiplied together, it will be giving us a squared plus b squared whole square, which is a constant term. So this should be equal to 400. We will be equating the constant terms of both the sides. So this should be equal to 400. And therefore, a squared plus b squared will be equal to, taking the square root, this should be equal to 20. Okay. And I can try the getting the coefficient of the term containing z cube, because trying the z to the power of 4 doesn't help. If we if we multiply z times z times z times z, you will be getting z to the power of 4. It doesn't help. So let us try to get the coefficient of z to the power of 3 from the left side. How can we get the value, the coefficient of z to the power of 3? How can we get to z to the power of 3? We can get to z to the power of 3 only when we multiply three constant terms from, let me say I'm multiplying this term with this term. This is a constant term. This is a constant term. This is a constant term. So if I multiply these three and these three when multiplied with this z will be giving us, sorry, I I'm mistaken. I want to get the term containing z, not z cube. So I can get the term containing z by multiplying three constants, and the product should be multiplied with 1z. Yeah. So let me do that. I could have got this z cube also. What do you say? Should I be taking the z cube, or should I be taking the z? Okay. I'm assuming since I have said z cube, so okay, fine. Let us take z cube. It is up to you. It doesn't matter which one you are taking. Okay. Z cube, how to get to z cube? I will be multiplying z times z times z. I'll be taking three z's from these three factors, and I will be multiplying the z cube with one constant factor from the fourth factor. Only then I'll be coming to z cube. Okay. So let us first of all take the first one, the second one, the third one. So z cube, and I'm taking the constant term from the fourth factor. Z cube times negative b minus ai. Negative b minus ai, so I can write minus b plus ai. Okay. Next, I am done with the fourth one. So let me just bracket it so that I don't take it once more. Now this is gone. I have to, let me do the first one now. Now it is the turn of the first bracket. First factor. So I'll be taking z times z times z, and I'll be multiplying with this. So this plus z cube it will be minus A minus BI. Okay. So these two are taken. Now let us take the second one. Again, it will be Z cube. And this is minus A minus BI. So let me write minus A plus BI. And finally, this one. So B cube, and this is minus B minus AI. Since we have taken Z cube, we have to take the coefficient as 4. So this is 4Z cube. And I am taking Z cube common. I'm taking it out as the common factor, and it will be minus B plus AI minus A minus BI minus A plus BI minus B minus AI equal to 4Z cube. These two will be getting cancelled, and AI minus AI and minus BI plus BI, they get cancelled, and I am having minus 2A minus 2B. So it is minus 2A plus B is equal to 4, which gives us the A plus B value as 4 divided by negative 2, which is negative 2. You see, A square plus B square equal to 20 and A plus B equal to negative 2. We had got exactly these two equations in our previous method. See, A plus B is equal to negative 2 and A square plus B square equal to 20. So it doesn't matter which method you are using, you will be getting these two equations and you have to solve them to get the values of A. Okay. So now I have solved this question, and after seeing all this, you may be wondering, who am I? I'm Nilanjana Sanyal. I tutor IB Math A, HL and HSL students. And to be more specific, I tutor kids of Indian parents and the NRI parents. And currently, I have a desire to conduct group online math tutoring sessions for Indian students. If you have given the IGCSE, if you are starting your IB Math ASL or HL course and you are interested in group online sessions, please do contact me. The contact numbers, you may text me, you may mail me. The numbers are given over here. You can see them. Okay. And thank you for staying with me till the end. We will be solving question number 8 tomorrow. So till then, bye.